Hi everyone, welcome to our channel. In this video, we are going to see the concept of modular arithmetic. So what is modular arithmetic? It is a system of arithmetic for integers where the numbers wrap around a certain value. Now this system processes cyclically. For example, days of a week occur cyclically. How? Let me take from Sunday. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, it goes on. Now in a 12-hour clock, 1, 2, 3, 4, it goes on up to 12, and for the 13th hour, it goes from 1, and for the 14th, it goes on 2, like that. And day and night and day and night, it goes on cyclically. Now this system of wrapping around a certain value, we call them as modular arithmetic. Now let us see the definition of congruence modulo n. Two integers a and b are said to be congruence modulo n if they differ by an integer multiple of n, that is a minus b equal to kn for some integer k. Now this can be written as a is congruence to b mod n. Now if I have to put all these things in the very simplest form, a minus b should be divisible by n. That's it. Now here let me take the example 61 congruence 5 mod 7. Now here 61 minus 5 is nothing but 56. Of course 56 is divisible by 7. Again 47 is congruence to 3 mod 11 implies 47 minus 3 equal to 44, which is divisible by 11. Now to find 8 mod 4, you know that 8 is exactly divisible by 4 and the remainder is 0. Therefore 8 is congruence to 0 mod 4. To find minus 5 mod 3, let me take the next integer that is divisible by 3. So let me take 6 here. And also I have to check when I subtract 6 with 5, I should get a positive integer. Now so here 6 minus 5 gives me a positive integer. Therefore minus 5 is congruence to 1 mod 3. Again let me see another example, minus 11 mod 4. Now let me take a number that is divisible by 4. So 12 if I take, when I subtract with 11 I get 1, which is again a positive integer. So minus 11 is congruence to 1 mod 4. Now let me take another example, minus 74 mod 7. Again let me check for a number that is divisible by 7, and at the same time when I subtract with 74 it should give me a positive integer. So the next possible integer must be 77. Therefore 77 minus 74 gives me 3. Therefore minus 74 congruence 3 mod 7. Now let us see a problem based on this. Find the least possible value of x such that 98 is congruence to x plus 4 mod 5. Now as usual I am going to apply the formula. A congruence b mod n is nothing but a minus b equal to some 5n. So here 98 minus x plus 4 equal to 5n. Now let me take the minus inside. So minus x minus into plus gives me minus. So minus 4 equals to 5n. So 98 minus 4 gives me 94. 94 minus x equal to 5n. Now what is the least possible value when I substitute for x? It is exactly divisible by 5. So if I put 4 here, naturally I get 94 minus 4, which is going to be 90. 90 is exactly divisible by 5. Therefore the least possible value of x must be 4. Let us solve 8x congruence 1 mod 11. As usual, I am going to apply the formula. A congruence b mod n is nothing but a minus b equal to kn. Now here also 8x minus 1 equal to 11k. Now since I have to solve for x, keep 8x as it is and take the minus 1 that side. So 11k plus 1. And x equal to nothing but 11k plus 1 by 8. Now keep giving values for k. Now as I give values for k, it should be exactly divisible by 8 also. So when I put k equal to 5, I get x is equal to 7. So when I put k equal to 13, I get x equal to 18. And when I put k equal to 21, I get x equal to 29. And when I put k equal to 29, I get x equal to 40 and so on. Therefore, the values for x is nothing but 7, 18, 29, 40 and so on. So friends, I have taken the utmost efforts to make you understand this concept. I hope it has reached you, but please don't forget to subscribe, like and share. Thank you.